Hello everyone, I'm Rano and today I'm going to write some Python program which will track the International Space Station which is flying over the Earth at an altitude of 400 kilometers and at a speed of 17,900 miles per hour. That being said, let's get started with the coding practice. So I'll be explaining bits and pieces of the code as I go, and let's see how can we track that using some of the open source APIs out there. All right, let's start the function def uh, find ISS. So I'm mentioning my latitude here, which for this instance I'll take any arbitrary coordinates, but this can be your address, which you can just Google and figure out, like, what is your coordinate of your address. But so I'm writing, um, I'm writing the inputs that are needed for this program, and I'll be explaining that to you as well. Alright, so basically for this test I'll be using time square as the pinpoint from where we can calculate how far is the you know uh, how far is the International Space Station is. So let's take this values. 1 second. Okay, alright, this is the coordinate of time square and this is the longitude, and let's add the OpenCage API key. So this is another open source API which I am using in this project, and it will give, if you pass coordinates to this API, it will give you the exact address. For example, I pass this coordinate and click on geocode, it will give you this address. So you have to register to that. It will give you a token, and you can then use that token to further invoke this API. All right, and there is another API which is api.opennotify.org, and this gives the latitude and longitude of the current ISS position. So if I refresh it, you see the coordinates getting changed as the International Space Station is constantly moving and circling the Earth. So let's try to use this API endpoint as well in our code. All right, and the API key which I already have, since I've created a profile here, I'll just be using that. All right, now we have it ready. Now let's write a request function. Alright, and now this request function, let's convert it into a dictionary, since we'll be getting the response in JSON. Alright, now as a next step, what we have to do is write a for loop. Like, we have the data fetched in JSON, and if I execute this function, we will see, like, it has the data fields which are available. We'll take care of this inputs of the import parameters, which we can import it later, the libraries, so these errors will go away. But let's try to finish this code, and we will be trying to get the actual coordinates, which is the values of this, using a iterative function. All right, So as I have converted it into a dictionary, so it's easier for me to extract. If key equals to uh, ISS position, coordinates equals to value, which is the value of this one, the latitude and longitude. And then what we have to do is we just have to get the ISS latitude. Alright, now same you have to do for the longitude as well. And this will be longitude. Alright, so we have the ISS latitude and longitude. Now we have to calculate the distance from my location. For this project demo purpose, I have used time square. And you can also look for your coordinates somewhere, like it's available out there in the Google. So the distance will be calculated by one of the functions which we have seen. So basically there is a formula using which we can calculate the distance between the coordinates. There are details around the mathematical calculations, but we have Python libraries available which can help us to achieve what we want to do. So this is how it is being used, and we can leverage this in this code. So the distance can be calculated by using our scene, and all right, and all right, so this is the ISS longitude and latitude, and same has to be passed for this one as well, for my coordinates, which is my latitude and longitude, which is basically the time square latitude and longitude. All right, so we will be importing this at the end, but this is how it will look like. And the other thing which has to be passed to this is the keys, I guess. All right, yeah, open cage. No, I think that should be good. Oh yeah, like this is have a scene, so I don't need the keys. That's for the open cage. All right, let's do another step, which is geolocation is equals to find ISS location. So we'll be writing this function in a subsequent step, and this will be getting the coordinates, and we'll be converting that coordinate into specific addresses. So we will be doing it this way, and let's see, float my latitude. So basically I'm passing it the International Space Station coordinates along with the API key, and let's see if that works. So I'll be passing the API key as well to this. All right, and once it's there, we'll be defining the function, and a few things which I have to type basically here, which is so I'll be getting the distance. All right, another thing is what I can print is All right, so this step is done. And also we can add a small criteria, like if distance is less than 2, then print flying over you. Isn't that cool? All right, okay. Now we have to write and define this function, which is find ISS location. So let's copy this uh, and define the parameters as mentioned: ISS latitude, ISS longitude, and the open key. All right, so we also have let's name this variable geocoder. All right, and so similar to the have seen, this also has Python libraries available, and that can be looked here. We have a good documentation on this on the OpenCage APIs, and if you see, right, like they are using similar formats, like the geocoder, to call the methods, and then we just pass the inputs and it does the work, so we don't have to define all of the coding part, which are being taken care by the libraries available. All right, we will be adding just just a name to this, and then we'll be defining the imports. Or a good idea is to define the imports, and then we can go ahead with the next steps, so it's more of a it's more it has some clarity in it. All right, so import pip dot underscore vendor for importing the pip the request modules. Then we also have to import the JSON. Then we also have to import what have a scene. All right, import, not import, it should be from OpenCage from all right, we have the imports which are necessary here, and then just with this. Now what we have to do is we just have to pass the API key for authentication to this endpoint API. Once that is authenticated, what we can do is we will be using the other function, which is geocoder.reverse geocode, and then pass the coordinates to this in form of latitude and longitude. All right, so that's there, and now just we have to do is return the results. And at the last, like, it looks cool, and at the last we have to call this function so that it executes fine. All right, so let's see, let's try to run this. All right, we see the data coming up. Its distance from Times Square is this, and we can add some kilometers to this. So all right, 8046 kilometers, and there's a lot of details on the exact location or the address from the OpenCage data API. The exact address through which it's flowing, and if you see closely, like, it's flowing somewhere over Ukraine, and the country code, the district name is Volnovaka, rain, municipality as well. So a lot of details coming up. So let's filter some of the details here, and for that what we will do is uh, we will just pick one of the components which is uh, you know one of the key pairs, and then try to filter from the annotations so that we get the exact details inside the components. So let's try to add one more, and all right, let's try to paste this. So let's see. All right, so the distance is 8471, ISS is about geolocation, and you see the municipality name, and maybe it's Russian, and it's kind of, the more you execute it, you see the distance kind of increasing or decreasing based on the current location of the International Space Station. So let me try it one more time. So you see it's 8471, now it's 8635, so it's moving towards the US. And yeah, it's 8698, and yeah, it's decreasing slowly. I mean, yeah, it's increasing slowly, to say. All right. Okay, and yeah, that is the fun. Like, we just wrote a small program which can track the International Space Station. You can put in your coordinates, your address coordinates, and it will show you this. uh, we can use some of the AWS functionalities here as well to, if this condition is satisfied, we can have some event scheduler which, scans it at a cron schedule, and it sends an email or alert using uh, simple notification service, or we can get those alerts configured to the desired email address or maybe the telephone number, whoever is subscribed to those topics. But yeah, like, a lot can be done from here, but this is the base of the code. Like, we can track the International Space Station, and that's cool to me. Okay, and if you have any questions, suggestions on this, or how this can be made better, please let me know. And meanwhile, we can validate this as well. Like, what you can see is current location of International Space Station. So it will show us, not this one, but this would show us where it is currently located. So if you see here, it's over the ocean, and now it's slowly moving into the land somewhere uh, in Asia, right? So if I refresh it, we can see the details as well. Like, it is into Asia, it's traveling over Turkmenistan, and in the map as well we see it's traveling over Turkmenistan. So that's the beauty of this function. I'll be uploading it in my GitHub, which I'll provide the link in the bottom of this video. But feel free to subscribe and provide some suggestions on how we can make this better, or what could be an use case of this, and I'll try to make it more useful and interesting based on those comments. Thank you for watching. Stay tuned.